weight is a vector quantity, and it measures the amount of gravity. The gravity acting on a body. Okay. So these are the major things we need to understand about weight. Number one, it's a vector quantity. It's not a scalar quantity, but a vector quantity. A vector has both magnitude and what? Direction. Okay. So it's a vector. The word vector means direction, right? Now, the weight measures the amount of gravity. Okay? When you're lifting up something, then there's a gravity pulling it down. So you're going to measure the amount of gravity of what you're trying to lift. Okay? So an object, all objects are attracted by the gravitational pull of Earth. All objects, that's why I gave an example of when you are trying to lift something, because it's like you are fighting against the gravitational force. Okay, the Earth is pulling it down, you are pushing it up. Okay, so because of that gravity on Earth, you know, every object is going to be attracted to that gravity. It's like this gravity is a magnet pulling any object to the ground, and you're trying to pull the object, you know, from the ground. Okay, so now when you measure the amount of the gravity, that is the amount of the gravity that is found in that particular object, okay, because of the gravitational force which is pulling it down, then you are calculating what? Weight. So an object which with more mass experiences greater gravitational force acting on it. So when a certain object has more mass, then expect to have a gravitational force, okay, a greater gravitational force acting on it. Okay, the smaller the mass of an object, the smaller the gravitational what? Force. Okay, now let's look at the second Newton's law of motion. According to this, the Newton's second law of motion, Newton is just the name of a scientist, I mean a scholar, okay, who did a lot of things in science. So according to his law of motion, motion means movement, okay, according to his law of motion, he says weight can be calculated simply by, how can you multiply weight? I mean, how can you calculate weight? You get the mass of what? Of the object you are calculating, multiply it by acceleration due to gravity. That is according to Newton's second law of motion, where he says when you're calculating weight, you need to multiply these two. Mass multiplied by what? By acceleration due to gravity. That is, weight is equal to mg. So this is the formula that you can use when you want to find the weight of an object. So I think you are getting sense here. There's a difference between mass and weight. Mass is the quantity of matter contained in a body, while weight is the force with which a body is attracted towards the earth. The other thing you need to understand is mass of an object can never be zero. Okay? But with weight, it depends on the what? On the gravitational force. If the gravitational force is zero, then weight is also zero. So that is what we need to understand here. Okay. So it is also important to understand the units for weight, the units for mass, the units for acceleration due to gravity. Okay, very much important. So the G is also known as the gravitation field strength, which has the same magnitude of 9.81, but the different SI unit, International System Unit, these are, okay, NkG negative 1, NkG negative 1. Okay, so this is what we need to understand about mass and weight. Now let's look at the differences. Number 1, mass is the quantity of matter contained in a body, while weight is the force which a body is attracted towards the earth. Difference number 2, mass of an object can never be zero, while weight of an object can be zero if the acceleration due to gravity is zero. Number 3, mass is a scalar quantity, while weight is a vector quantity. Number 4, then it is measured, that is mass. Mass is measured by a beam balance or a physical balance, while weight is measured by a spring balance. Number 5, the units for mass are kilograms or kg, while the units for weight are newtons. The sixth difference between mass and weight is mass is constant, and it is also independent of the place and position of the body, meaning it does not change either it's on earth, it's on the outer space, or moon, right? It remains the same. But with the weight, all right, weight changes depending on the gravitational force. So those are some of the differences between the two. Okay, now let's try to understand this, because we are just talking about, no, mass doesn't change. It's not changed because of its location, speed, or its shape, but weight changes because of its location, right? Why? Because of the gravitational force. Now let's look at this information which shows the mass and weight of an astronaut when he travels from Earth to Moon. Okay, so this man will have a particular, will have a certain mass when on Earth. What will be the certain, the mass when on the moon, or when he goes to the moon? What will be the weight when on Earth, and what will be the weight when he goes to the moon? You're going to find that mass will remain the same, but weight is going to be affected because of what? Its location. Because of its location. Remember, weight is is a vector. Now on Earth, this man has 84 kg. The mass of this man when he's on Earth is 84 kg. Okay? When he's on Earth, his weight is 840 newtons. How do we find this 840 newtons? We need to know that the gravity of Earth is about 10 newtons per kg. What happens when this man goes to the moon? The mass will remain the same. The mass never changes because of its location, size, or speed. So the mass is going to remain the same. But his weight is going to be affected because the gravitational force of the moon is not the same as the gravitational force of the Earth. The gravitational force of the Earth is 10 Newton per kg, but the gravitational force at the moon or of the moon is about 1/60 of the value of Earth. It's 1/6 of the value of the gravity on Earth. So which is same as 1.6 Newton per kg. So if you now calculate the weight of this man, it's going to be affected, it's going to change. It's no longer going to be 840. Okay, why? Because the gravitational force has what? It changed. And you multiply the kg, which is 84 kg multiplied by the 1.6 newtons per kg, and it's going to give you 40 newtons. What if this man goes to the outer space? The mass will remain the same. The mass does not change. It will remain the same. Now, guess what? The outer space doesn't have any gravity. So if the gravity is 0, when you multiply anything by 0, it's 0. So the weight of this man will be nothing, but the mass will be the same. So the mass is not affected, but the weight is affected depending on its location. When it's on Earth, it's 10. The gravity is 10 newtons per kilogram. Then on the moon, it's 1.6 newtons per kilogram. Then in the outer space, there is no gravity. All right, because that place is far away from the Earth, and the moon is nearer to the Earth. That is why you can see some gravity on the moon, but the outer space is just far away from the Earth and there's no gravity. So that is why you find the weight is what affected.